Hello, hello. So you should be watching this video if you had trouble with the homework that was due today, which was 1-53 and 1-55. So I'm going to take you through that just real fast. Okay. So 1-53. Take a minute. You should have read this already. Um, but basically, it says a function works like a machine. It's the whole idea that we've talked about, like inputs and outputs, right? And you can see that here over on the side. Like there's an input and there's an output, right? So this is the function. This is the function right here. And this is an input and this is an output that corresponds with that input, okay? So that idea should not be new for you. You know, that's what we've been talking for the last couple of days. This idea of like function notation, giving the function a name, that part might be new, okay? So this says right here, that says f of x, okay? Now, that's how you would read that. That is literally just naming a function. Let me kind of give you an example. Like, I could say, here's a function, y is equal to x. And then here's another function, y is equal to 5x minus 7, okay? And if I were to say, I could say then to you, like, evaluate the function when x is equal to 2, okay? That could be my direction. Well, which function am I asking you to evaluate? This one or this one? It's kind of hard to tell. Function notation just gives a name to each function. So instead of saying the one on the left is y equals x, let me call that function f. So I'll call that f of x. So that function, y is equal to x, now has a name. And this one will have a different name. Pick a different letter. A lot of times we use G. You can use A of x. You can use B of x. It doesn't matter. So now I might, instead of saying evaluate the function for x equals 2, I might say evaluate f of x when x equals 2. Oh, that tells me that I need to plug into the one over on the left, the one that we called f. So I would just plug in f of x equals 2, done. Or I might have said evaluate g of x when x is equal to 2. And then I would plug into the other equation, okay? Now to get even fancier, if the directions say evaluate f of x when x equals 2, so I'm plugging in 2 for x, so my input is 2. This tells me my input, right? And I just showed you that my output would also be 2, correct? So my input is 2 and my output is 2. Now I can use this notation, f of 2 is equal to 2. In this notation, which the problem 1-53 talks about, this number in here is my input, and this number here is my output. That's all that really says. It's like nothing fancy, okay? So let me ask you another question. What if I said evaluate g of x when x equals 3? So that means that you would plug in 3 right here. So 5 times 3 minus 7, so 15 minus 7, and I'm running out of room. So 15 minus 7 is equal to 8, okay? Now, again, to get kind of fancy, I could say that this was g of 3. And therefore, g of 3 is equal to 8. Again, 3 is my input, 8 is my output. That's all that says, okay? So another way of asking this question, evaluate g of x when x equals 3, is I could just say to you, find g of 3. Okay? If I say find g of 3, it's asking the same thing. You would just plug in 3 for your input, just like we did down here, and we would find out that my output was 8. So g of 3 is equal to 8. All right, now my board is a mess. I'm going to erase all this madness. I'm sorry. Okay, so, all right. So I'm going to go through this with you. Find the output for f of x equals x squared minus 1 when the input is 4. That is, find f of 4. So f of 4 means that x is equal to 4. So instead of x, you're going to write a 4, okay? And now you're just going to simplify. This is 16. I'm using the order of operations. So therefore, my output is 15 when my input was 4. In other words, f of 4 is equal to 15. All right, so that's question A. Let's take a look now at questions B and C. So here's the same function, okay? So find f of negative 1. So f of negative 1. F of negative 1 equals, and now we just take this function and I plug in negative 1. When I square a negative, this means negative 1 times negative 1, it becomes positive. And so now I have 1 minus 1, which is 0. So f of negative 1 is equal to 0. All right, now I need to find f of 10. So I plug in 10 for x, and I just simplify using my order of operations. 10 squared is 100, and then 100 minus 1 is 99. So therefore, f of 10 is 99. When my input is 10, my output is 99. All right? Question C is asking you to kind of go backwards. If the output of this function is 24, what's the input? So that is, if f of x is 24, what is x? Is there more than one possible input? So let's answer that question second. So in other words, let's say x squared minus 1, that's our function, right? Now they're telling me that the output is 24. So in other words, when I put something in for x, and I simplify this, I get 24. So in other words, I can kind of just say x squared minus 1 equals 24. Well, let me solve this for x. To get x by itself, I would add 1 to both sides, and I would get x squared equals 25. Now, we haven't really talked about how to solve equations like this, but what number can I square it, and I would get 25 as my answer? Well, 5. If I take 5 and square it, don't I get 25? Yeah, so therefore, 5 could be a possible answer. But then this question, is there more than one possible input, right? So is there more than one possible input? Well, what other number can I square and get 25? If I square negative 5, I can also get 25. So those are my two answers, or my two inputs. So I could have 5 as an input. This tells me that f of 5 is equal to 24, but also f of negative 5 is equal to 24. In other words, I could have two different inputs and have the same output. Okay? All right, next one. 1-55. So you're kind of using the same thought process that we just discussed, all right? So you're kind of just plugging in. Let me make this a little bit easier to see. Oops. Oh gosh, sorry guys. Okay. All right. So for letter A, here's my function, and I'm plugging in x equals negative 3. So f of negative 3 is equal to negative 2 times negative 3 plus 4. I just got to simplify. This becomes 6 plus 4. So therefore, I add them together. F of negative 3 is equal to 10. Okay? For letter B, f of negative 2 is equal to the square root of negative 2 plus 3. Order of operations tells you to do this first. So the square root of negative 2 plus 3 is 1. What's the square root of 1? The square root of 1 is 1. So therefore, f of negative 2 is equal to 1. Okay? So just keeping in mind, as you answer these questions, you got to follow order of operations. Okay? So if you need to go back and check some of your answers, I do want to go over F with you, because F, A, B, C, D, and E are very similar. They give you the input. They ask you to just plug in and find the output. Oh, along with H and I. But F and G are a little bit different. Here they're giving you the
output and they ask you to find the input. So let's look at F together first, okay? So F,
just like we just did on the previous slide, this is our output. So I can kind of say that x squared minus 1 is equal to 99, okay? I want to know what x is. This is what I'm trying to find. So let me add 1 to both sides. I get x squared is 100. And using that same reasoning that we just talked about, what two numbers can you square to get 100? Well, if I square 10, I get 100, but also if I square negative 10, I get 100. That tells me that f of negative 10 is equal to 99, but also f of positive 10 is equal to 99. Okay? The same thing with G, all right? This is my output. It's asking you to find x, find the input. So I can say the absolute value of x is equal to negative 3. So it's saying, can I find an x value? Can I take the absolute value of a number and get a negative? Well, remember, absolute value is the distance a number is from 0. So can distance ever be negative? Can the distance that a number is from 0 ever be negative? No, not in this case. So we would say there's no solution. There's no possible way that we can put an x value in here and come up with an output. So in other words, I can't ever put an input in and come out with an output of negative 3. This is impossible, okay? All right. So now that you've kind of gone through that, you might want to take some time, look back at your homework again, and then you can pause the video. Here's homework answers. So take a minute. You can look at these homework answers. Again, if you're still struggling, go back and rewatch. Thanks. Have a good one.